Hello, this is Mr. Stansbury. We're going to finish up the 16 F notes on sine functions. Okay, so again, just to kind of refresh you with where we left off, this number here in front of the sine affects the amplitude. The number that goes with the x affects the period. And then the number after here at the end is the vertical translation. Okay, so we're going to use that info here to graph these two graphs here. Okay, so we got y equals 2 sine x plus 3 and y equals sine of 2x minus 3. You want to remember here, this is pretty important. You really are going to want to commit to memory what the sine graph looks like. Okay, starts at 0, maxes out at 90, back down to 0 at 180. It's at the minimum at 270 and back to 0 at 360. Okay, so this here, I usually like to work these things from right to left. It usually seems to make it a little bit easier. This 3 here tells me that this whole graph is going to move up 3 units. So I'm going to do this. I'm going to just draw my principal axis in here at 3. So I know up here is my new principal axis. This is my new 0, basically, from over here, right? And then the amplitude here is 2. So I know that this thing is going to go up 2 and down 2 from the principal axis. So here's this is my max, and this is my minimum here. All right? So let's see, that's taking care of everything. The amplitude hasn't changed because there's nothing with the x like B has, so I know that it's going to repeat at 360. So let's see, let's do this. So I know at 0 it's going to start at, at 0 it's going to start, 0 degrees is the start right here at the principal axis. And then remember halfway through, well, let's see, it takes, how about this? It takes a full 360 degrees to get through one full period. So it's going to start here and end here. Halfway in between on this here, it's back at 0 again. And then halfway in between these 2 points here at 90, it's going to be maxed out. And halfway between these 2 points, it's going to be at 270. It's going to be at the minimum. Okay, and then this whole thing is just going to repeat, right? So another 360 degrees, which is out here at 720. It's going to end its period. Halfway in between, it's going to be back at 0. Halfway between these 2 points, it's at the top. Halfway between these 2 points, it's at the bottom. And we can now connect the dots, or at least I can try to connect the dots. All right, you get the idea. All right, so that's kind of what our 2 times sine x plus 3 graph should look like. Okay, with same idea here, let's try this one here. Again, I'm going to start at the right and work back to the left. So -3 means the whole graph has gone down 3. So there's my new principal axis. Right? Instead of 0, let's put principal axis here at 0. There's no number out front here, so you have to assume that that is 1. So that means the amplitude is 1. So it's going to go up 1. So there's our max. And then it's going to go down 1 from that point right here, which is our minimum. Okay, so I guess I didn't really work from right to left. I did this first. I did this second. And then the last thing I'm going to do is this here, the thing that affects the period, right? So what I do is I take that 2, I'm going to take 360, and I'm going to divide it by that 2 to give me 180. This is my new period. Okay? So I know that this thing is going to take 180 degrees to repeat. So what I'm going to do is I know that it starts at 0, and now I know it repeats every 180 degrees. So every 180 degrees, it's going to be back down here at 0. 180 degrees, back at 0, 180 degrees, back at 0, 180 degrees, back at 0. I know that halfway, but here's the beginning, here's the end. I know halfway in between those points, it's going to be back at 0 again. So I know halfway in between these, it's at 0. Halfway in between these, it's at 0. 0, 0, so forth and so on. Halfway between these 2 points here is the max. So halfway between here, these two is the maximum. Halfway between here is the minimum, maximum, and we can just kind of keep bouncing this thing back and forth all the way to the end of the graph. All right, and then here's where you get to laugh a little bit, because now you get to watch me try to connect all these dots on this tablet-y thing, and it gets pretty bad. Oh, hey, look, I'm doing all right, but of course now that I've mentioned it, something's going to go wrong. It's not so bad. So that's what the graph of this one here looks like. Okay, y equals sine of 2x minus 3. Okay, so now we've been able to graph all these. The next thing we're going to do is find the equation of a sine graph. But before that, let's watch a little video, shall we?
Remember there was a plot to kidnap Russell Crowe? That's true. It was a kidnapping plot. For the life of me, I don't know how anyone would ever come up with an idea like that. There's some guy sitting at his checkbook, you know, trying to pay bills. Honey, I don't know how we're going to pay this Visa bill. Oh, yes, I do. What was a spark? I got that plan rolling. We're getting Crow. How are you going to pull that off? I mean, like, maybe see him at a public event. Excuse me, Mr. Crow. Just wondering if I get an autograph. Yeah, all right, you got a pen? In my van.
All right. Anyway, so last thing we're going to do here is find the equation of the sine graph. So given a graph, you're going to actually go through and find the equation. Okay, so let's do this here. We have, it starts right here at 0. This here is going to be our, whoa, here we go. This is going to be our principal axis, right? This is right down here in the middle. Okay, so there's our principal axis, the PA. And then looks, it maxes out up here. So this is the max. And then the minimum is down here, right? So let's see, it takes, there's 360. Here's where it finishes. And now we know that the period is 720 degrees. So now here's how we go backwards and find the equation of this graph. So again, we have y equals a sine of bx plus c. Okay, so remember, probably the easiest thing for me anyway is I'm going to start with my vertical translation. Okay, so I know the whole thing goes up 1. So there's my plus 1. That's my c. Okay, this a here is the amplitude, right? So we got y equals amplitude from here to here is 2, right? Now, here's the tricky part. It doesn't start by going up like it should. It starts by going down. So that means this is going to be negative. So whenever this, remember, whenever it starts by going down, that means that it's negative. If it started by going up, it's positive 2. It starts by going down, it's negative 2. Okay. Last thing we need to figure out is what the b is. Okay. So the b, if you'll remember, we always took 360 divided by b, and we got the new period, 720 degrees, right? So a little bit of nice math here. Multiply both sides by b. 360 equals 720b. Divide by 720. And b equals 360 divided by 720 is 1/2. Okay? So if they, remember, if they give you the b, you took 360 and divided by b to get the new period, right? Now also with that, you can take 360 and divide by the period to get the b. Okay, so these are kind of handy little formulas to have. Either way, just remember you take 360 and divide by whatever they give you. Okay, so this case here we have 1/2x. So the equation of that graph here is y equals negative 2 sine of 1/2 x plus 1. Okay, and just to show you, here is that graph. Starts off by going down and comes back up, and it ends at 720. Highest point's at 3, lowest point's at negative 1. And look, there it is. Highest point is at 3, lowest point's at negative 1. Takes 720 degrees to repeat. All right? All right, so that's it. You should be able to now say that I can find the vertical and horizontal dilation of a sine function as well as its vertical translation, and also I can find the equation of a sine graph. If you have any questions, please ask. Thanks.